سهل إلا ما جعلته سهلا وأنت تجعل الحزن إذا شئت سهلا. أهلا بكم إخواني الكرام في مصنع بيكاترونكس.
Becatronics Training Department, illustration on how to work the rotary on the CNC router machine. Today we'd like to welcome you in the Becatronics factory. We will discuss the practical training on the fourth dimension. Before, in our training, we discussed how to make designs on the ArtCam and how to operate the machine in the normal position. As I said before, today we will discuss the fourth dimension, or the rotary as they call it. It's very easy to use the rotary. A lot of people think it's hard, but it's not. Whoever knows how to work the router in the normal position or has some background information about the ArtCam or the router operation in general should find it easy to learn how to work on the fourth dimension and should not take more than half an hour to learn so. Learning how to work in the fourth dimension is what we are going to do in a collection of lessons. We'll start with the piece of wood that we would be working on, which is square, and then we'll execute the file that we made on the ArtCam. Executing the file on ArtCam was illustrated in the previous lessons, which explained how to make a design on the ArtCam to make the surface smooth and clear. Then we make the piece of wood cylindrical in order to apply the design file on it, whether it was 2D or 3D. Now this part, you'll find this part of the wood attached to the machine. This is the lathe rotary section. The rotary has an area of about 220 centimeters. This part is for balancing the working table. We are going to start by unscrewing these screws. Here in the first screw, okay, then the second, then the third, and often I finish unscrewing these screws. We take this away. Then we will learn how to install this piece of wood on the lathe. At the beginning, if the piece of wood is not processed, we will draw across here in order to determine the center where we will fix the piece of wood. The piece of wood can be fixed whether on the moving or the fixed side of the table. Then we start fixing the piece of wood as we will see now. We put the piece of wood at the fixed side first, then we fix it in the marble side, where we keep turning the wheel till this screw comes in the middle. We cannot afford to have the piece of wood moving from either side, and we have to make sure that it does not turn if we turn it by hand. The piece of wood cannot move at all. In this lesson, we are going to deal with the control program of the control unit, which we will use to control the machine. This is a very important lesson and is considered to be the first lesson in executing a work on the rotary. As we said before, the first file, which is launch Beca, and is indicated on the screen with an icon. We use this file to control the machine in the normal position. Right below the first operating icon, we'll find the second operating icon, and is named Launch Beca for Access, as in the operating of the fourth axis. This operating icon is used to control the lathe or the rotary. So we do not use this second application unless we are going to execute a program on the rotary. Now we will double click on the icon that I mentioned before. Of course, we have talked before about how to turn on the computer and operate the machine. All that was mentioned before in the lessons provided by Becatronics. After I initiate the program, I will get the screen that you guys see now on the video. In the normal position, we used to click Home All when we open the application in order for the machine to go back to its 0 point. In our case, we don't have the Home All button, but we do have a home button for each axis. So we choose the axis that we want to work on, and then we hit home. Over here, we'll notice that there's an icon or a mark for an axis called A that appears on the screen. This A axis is considered to be the rotary or the fourth dimension. So we do have the X, Y, and the Z axis as we know it, and then we have the A axis as the rotary axis. The first thing I do after I initiate the software is to hit home as usual, but a different home button as we explained before. Choosing the right home button is very dangerous, very sensitive, so we have to be careful because we have a piece of wood that attaches to the machine. We have pieces that make it not moved and fixed, so we have to be very careful with it. And we must be very careful not to hit any other piece of work while we're working. That's why Becatronics were very keen on making a home button for each axis, so no one gets confused and God forbid an accident happens. And before we get down to really execute that, as we said before, we will notice something. We notice that when we hit home for a certain axis, it doesn't go right back to 0 as we used to in the normal position. So in this situation, the only thing that moves is the X, which is the one that puts it's the one that makes it go directly to the middle of the piece of wood. So when we push home for the X, we'll see the machine moves and goes to the far left, then moves to the right for a distance that's pre-programmed, and finally stops right in the middle. Everything else we see on the screen right now is what we had before and we all know about from previous lessons at Becatronics. In the bottom and the far left of the screen, we'll notice something new that was added and we didn't have before. We will notice from down bottom there that there's few new orders in the Becatronics application. Let's see together what we have here. The first one goes to the speed of the machine during the cutting process. We can increase it or decrease it as we see, and it's like a percentage that we already programmed in the ArtiCam file. Then we have the rapid override, which is the speed of the machine during the movement from one point to another, which we call save Z, and the speed is called rapid override. Then we have the spindle override, which is the speed of the spindle during the cutting process. Then we have the drop speed, which is the free motion speed when I move the machine manually by my hand from one point to another. Then we have the different function here, which is another drop speed, which is considered especially made for the rotary section. This controls the speed of the rotary in the air while working. Then we have max velocity, which is the production of my machine and the speed of the production while the machine is working. So now if you push the plus, the piece of wood will move to the right. If we push the minus, the piece of wood will go to the left. And now we'll see how it goes faster if we increase the speed by using the drop speed that we talked about before. And if we have 1 millimeter or a half millimeter above or below what we desire, we can change that from the continuous, as we said before in our Becatronics lesson. From the continuous, we can change it from a continuous movement to a step-by-step movement. So after we, in this screen of Becatronics application, we use the home button for the machine, and as we said at the beginning of the Becatronics lesson, we always use the home button to start the machine from the zero position. When we use the home button, the axis doesn't actually move, but as we see the icon on the screen, it means that the machine is already ready to execute the orders that we are going to do. And in this case, the only X is the one that's going to move, not all the axes. And it moves to give me the exact center of the workpiece. But we have to be very, very careful where we stand in the X and the Y axis. We have to make sure that the piece is high enough, so when it moves the X, it doesn't break anything or hit anything else. The same thing goes to the Y axis, where it cannot be below a certain level. We have to watch it very carefully so it doesn't hit or break anything when it moves. We have to really be careful with these two things so we don't break or hurt anything around them. So as we always say in the Becatronics lessons, we bring the Z to the lowest that we can, as far as like 1 millimeter from the point that we talked about, and that will give us the greatest area possible to work on, because most pieces work in such applications require a bigger space to work on. Another very important note in our Becatronics lesson is that when we hit the home button for the X or the Y axis, that means that it's the end of the movement space available to you. So for example, if I made home button for the Z axis and the spindle wasn't high enough, like in the middle of the space to the Z axis, that means that's the end of the space available to it, and we have to release the home button first before moving the spindle. And we learn from previous lessons in the Becatronics training section how to undo home. It's from the machine list where we do unhome, and then we unhome the axe that we need to unhome. So we have to make the axe as high as possible, so when we hit home, we cannot make it any higher afterwards. This also goes to the Y axe, so when we hit home for the Y axe, and it was at certain heights, we will not be able to make it any higher after hitting the home button. And in that case, the Y axis will not go to the back, as we will show later on in the Becatronics lesson. And why did we do that in the programming? We did that to protect you and protect the workpiece. This way, it cannot go back any further, and that will protect you and the working space as said before. Now let's see that in action. Now we choose the X axis and we hit the home button, while I must be sure that, like I said, I must be sure that it's at certain heights that will protect the workpiece, the workspace, and the person operating it. And then we'll see how the machine will move after we hit the home button for the X-axis. So now we're going to hit the X, the home for the X, and we'll see that it moves all the way far to the left, then goes all the way to the right to the right. And you must be ready to hit escape at any time, so if you see the machine will hit anything or breaking or hurting anyone, you can stop it at any time. This is the home of the X-axis, and this is the only one that has a movement when you hit the home. And as you can see, it stopped right in the middle of the workpiece, the piece of wood, right in front of the other piece. Now when we want to adjust the X and the Z axis, and also the A axis, first of all, the A axis is very easy to adjust. As we said, for the A, it's very easy. We just adjust the piece of wood as we want it for the start of the work. So if you want it straight, if you want it a little bit on this side or that side, we just do it as we want. Now, as we finish with the home for the A axis, we go for the home to the Y axis. The home for the Y axis is considered to be the first point where you're gonna start your work. As we can see here, if we want to start the work from the beginning of that piece of wood, we have to have the spindle standing right on the beginning of the piece of wood, and that's the home of the Y axis. So the maximum point that we can reach is the point where you hit the home and choose the axe, and that's why you have to choose carefully. And that's why we said before in the Becatronics lesson that we choose the beginning of the piece wood if we're going to start the work from it. As the Z axis, we try to get the maximum space available, because the bite may be long, the piece of wood may be big, so we try to get the maximum space available for the Z axis. The maximum space available is the one right under the limit switch, and we explained before in the Becatronics lessons what the limit switch is. So we can choose the home for the Z axis with about 1 millimeter under the limit switch. Now we get back to the console and we choose the Y axis or the piece 4. Right here on the 1913, we choose the Y right at the beginning of the piece of wood as we see. We will notice the machine didn't move or do anything, but at the same time we notice that the machine have the sign of the icon Y. Then we choose the Z on the screen and we hit home axis. So it put the thing on the Z axis and the machine didn't move. Then we choose the A axis and we hit the home axis. We also noticed that the machine didn't work, but it put the sign on the axis that we hit the home for. Then we move the machine in the direction of the Y axis, as you can see here in the Becatronics document. As you can see, it moves forward, and when it moves back, it stops right at the home button as we choose it, which was the beginning of the board piece. And as you can see also for the Z axis, we can go down, but we cannot go higher than the home point that we choose, which under the limit switch, as we said before in the Becatronics class. So that's all we have to say about home. Home is a very important point of work, and we have to be very careful when they execute it, because that's how the work starts and ends correctly. So please be careful and follow the directions. 2030, we have now inserted the flash drive and minimize it from the main screen where it says Becatronics. The flash drive icon will appear on the main screen as we can see. Then we click on the icon of the flash drive, and then we get the files of the report of the files of the ArtCam that we did before. I would prefer to put it on the desktop in any way you want, like we draw it outside or just copy and paste, or any way you see easier. Or you can create a new folder and move it in it and put it on the desktop. The piece foot is square and the rotary can make it round, but my advice to you guys is not to do it on the rotary. Why? First is because it's gonna use my machine, my bytes, the whole 9 yards, which means consuming your time and your money. So what can we do to save time and money? My advice to you is never use a piece of wood like this. Instead, use a piece of wood that's already round, and that should save you a lot of time and money and make the lifetime of your machine a lot longer. Or if you cannot do that, just try to break the edges a little bit closer to be round, like make it A-shape piece of wood, or use a saw or any other machine in your place. 2258, we now gonna use a piece of wood that is not square, but it's not really fully round, and it's not really clean all around. I know, like I told you before in the Becatronics lesson, that we have to make it round. We are going to make it round, but it's gonna take much less effort and machine work, and for that will save us lots of money. This piece of wood is about 80 centimeters long, and like I told you at the beginning of the Becatronics lesson, how to fix the piece of wood between the 12 points and how to screw the screw right under the end of it so it doesn't move while working. 24, now we have to start working on the piece of wood, and we're going to increase the speed of work, which is the speed of movement or the speed of the cutting. As you can see, the clean is done, the roughing for the piece of wood is done beautifully. And as we notice, we are down like a milli or half milli to cover the last part which was missed before. After that, we change the bite from the roughened bite to the clean one. So like I said, we took off the bite of the roughen and we installed the finishing bite because we're going to execute a 2D file. This 2D file is a normal file, as we said before in the previous Becatronics lessons. It's a very normal, very easy cutting file. 2524, we have now moved the machine back to its home point. Now we're going to make touch-ups for the Z axis. We'll start over it all over again. We'll take it easy, step by step, and we'll do the Z axis. We change the movement type, we make it by millimeter. And you can see that while the bite is going down the V-spot. Now we can hit run, but if you worry a little bit about what's going to happen, you can also close the feed rate to see what's going to happen when you hit run. Now we can increase the speed little by little. And as we can see on the screen of Becatronics, that the machine started the execution of the file. In 754, we have noticed that after the machine finishes, it went back right to the 0 point, which we adjusted as the home point for the machine. And as you can see, the 2D file is very easy file, short one. And why did we choose it as Becatronics is because we don't take long and we don't waste your time. And it's about the same idea if it's 2D or 3D. And you see a lot of our products doing the same thing in a very easy way if you just follow up with the Becatronics lessons. And as we explained in other Becatronics lessons, we did explain many 3D files before, and we executed right in other videos, but in this one we would like to make it short and clear. That's why this file was too easy and it took about 2 minutes to execute. As always, pleasure to meet you, and we are here to answer any questions you might have. You have all our information on the video. Thank you. You can also visit our website at www.becatronics.com and check our products, our machines, our spindles, and all our information, phone numbers, Facebook link, and videos link. Thank you. Have a great day.